Good morning everyone present here. This is the small description about the engineering thermodynamics. The engineering thermodynamics is the aspects related to energy and energy transformation. This is applied for the power generation, refrigeration and relationship among properties of matter. The energy is the ability to cause the changes. The name thermodynamics stems from the Greek words thermal, heat and the power. During an interaction, energy can change from one form to another, but the total amount of energy remains constant. Energy cannot be created or destroyed. The first law of thermodynamics, that is an expression of the conservation of energy principle. The first law asserts that energy is a thermodynamic property. The second law of thermodynamics, it is assert that energy has quality as well as quantity, and actual processes occur in the direction of decreasing quality of energy. The thermodynamics is classified into two types, that is the classical and the statistical thermodynamics. A classical thermodynamic, that is a macroscopic approach to the study of thermodynamics that does not require a knowledge of the behavior of individual particles. Statistical thermodynamic, that is a macroscopic approach based on the average behavior of large groups of individual particles. These are the application area of thermodynamics such as the energy, refrigerator, aviations, power plants as well as the human bodies, heat generation and transformation. That is the main concept of the thermodynamic, that is the system, surroundings and the boundary. The system, that is the quantity of matter or region in space chosen for the study. Surroundings, mass or region outside the system. Boundary means that is a real or imaginary surface that separates the system from surroundings. The boundary can be classified into fixed or movable, shared by the both, that is the system and surrounding. There is no thickness, no mass and no volume. The closed system, that is the controlled mass, a fixed amount of mass and no mass can cross its boundary. The open system, that is the control volume, the properly selected region in space. That is called as the open system. The control surface, the boundaries of a control volume, it can be the real or the imaginary. Next, the properties of the thermodynamic system. Any characteristics of a system is known as its property. For example, pressure, volume, temperature and mass, etc. Also the viscosity, electrical resistance, thermal conductivity is also the properties of the system. That is classified into mainly into two types, generally in three types. So that is the intensive property and extensive property. Intensive property is independent on mass of the system, for example velocity, elevations, etc. Extensive property is dependent on the mass of the system, for example pressure and density, etc. The specific property, that is the extensive properties per unit mass. State and equilibrium. Assume a system not undergoing any change, that is called as the equilibrium. Set of properties to completely describe the condition of the system is known as the state. The equilibrium means that is the state of balance. In an equilibrium state, there are no unbalanced potential within the system. That is classified into thermal equilibrium, mechanical equilibrium, phase equilibrium and also the chemical equilibrium. Thermal equilibrium, if the temperature is the same throughout the entire system. Mechanical equilibrium, if there is no change in pressure at any point of the system with time. Phase equilibrium, if a system involves two phases and when the mass of each phase reaches an equilibrium level and stays there. Chemical equilibrium, if the chemical composition of a system does not change with time. That is, no chemical reaction occurs. Then, the process. Any change that a system undergoes from one equilibrium state to the another equilibrium state, that is known as the process. The path, the series of states through which a system passes through during the process. So, the system, what state 1 to 2, that is the process, and the way of combining the process is known as the process path. And the process is known as the isothermal process, isobaric process, isochoric process based on the pressure, temperature, volume, etc. If the pressure remains constant, that is known as the isobaric process. The temperature remains constant, that is known as the isothermal process. The volume remains constant, that is known as the isochoric or constant volume process. Then, steady flow process. The term steady implies no change with time. The opposite of the steady is unsteady or transient. That is, the process process is change with time. A large number of engineering devices operate for long periods of time under the same conditions, and they are classified as steady flow devices. And that is known as the various types of process. If the volume is constant, that is known as the isochoric process. If the pressure is constant, that is known as the isobaric process. If the temperature is constant, that is known as the isothermal process. If the enthalpy and also the entropy remains constant, it is known as the isenthalpic or isentropic process respectively. That is a cycle. A system is said to have undergone a cycle if it returns to its original state at the end of the process. Hence, a sequence for a cycle, the initial and the final states are identical. The reversible process that can be reversed without leaving any trace of the surrounding. That is, both systems and surroundings are returned to their initial states at the end of the process. This is only possible when net heat and net work exchange between the system and the surroundings is zero for the process. Reversible or irreversible process. Most of the processes in nature are irreversible. Having taken place, they cannot reverse themselves spontaneously and restore the system to its original state. For example, hot cup of coffee. This cool down when exposed to surrounding, but warm up by gaining heat from surroundings. So generally, the heat is transferred from high temperature region to the low temperature region. But heat cannot be transferred from low temperature to high temperature region without any external devices. That is known as the irreversible process. Why irreversible process? Easy to analyze. A system passes through series of equilibriums. Serve as idealized model for actual processes to be compared for analysis, viewed as theoretical limit for corresponding irreversible one. Reversible process leads to the definition of second law of efficiency, which is degree of approximation, that is for closeness, to the corresponding reversible process. That is for better for the design, lower the reversibility, second law of efficiency. Temperature. That is a very, very important property in thermodynamics or thermal engineering. No exact definition. The broad definition of the temperature is the degree of hotness or coldness. This definition is based on our psychological sensation. Hence may be misleading. For example, metallic chair may feel cold than wooden chair even at same temperature. Properties of material change with temperature. We can make use of this phenomenon to deduce exact level of temperature. The temperature is denoted by the Celsius, Fahrenheit, Kelvin or Rankine cycle, that is the English system. That is the conversion factor from Kelvin to degree centigrade or Rankine to Fahrenheit or Fahrenheit to degree centigrade, Rankine to Kelvin. Next important properties in thermodynamics is the pressure. It is defined as the normal force exerted by a fluid per unit area. This is denoted by the unit Pascal, Newton per meter square, kilopascal, megapascal, bar, or atmospheric pressure. The pressure is denoted by the absolute pressure, actual pressure at a given position, measured relative to absolute vacuum, that is absolute zero pressure. That figure is clearly explained about the various types of pressure such as vacuum, absolute gauge, and atmosphere pressure. Next one is the ideal and real gases. Any equation that relates to the pressure, temperature, and specific volume of the substance is known as the equation of state. In 1662, Robert Boyle observed the pressure of the gas is inversely proportional to its volume, that is, PV is equal to constant. In 1802, Chollas and Gay-Lussac observed that volume of the gas is directly proportional to its temperature, that is, V by T is equal to constant. From this definition, PV is equal to RT. This equation is called as ideal gas equation of state. The hypothetical gas that obeys this law is known as ideal gas. R is the constant of proportionality given by the unit. PV is equal to mRT. Thus, for a fixed mass P1, V1 by T1 is equal to P2, V2 by T2, because PV by T is equal to constant. The constant is known as the mR. Behavior of a real gas approaches to that of an ideal gas at low densities, thus at low pressures and high temperatures. The density of the gas decreases and the gas approaches to ideal gases. That is the van der Waals equations. That is the thermal equilibrium. No change with respect to temperature, no temperature gradient. That is, a hot cup of tea cools with respect to time. Cold drinks warm up with respect to time. When a body is brought in contact with another body at a different temperature, it is transferred from the body at a higher temperature to that with lower one, till both attain a thermal equilibrium. A system is in a thermodynamic equilibrium if it undergoes no changes when isolated from its surrounding. Equilibrium corresponds to a state of balance. The system is at peace with all its poles and with its surroundings. Then heat and work. The energy can cross the boundary of the system in two forms, heat and work. Heat is a form of energy transferred between two systems by virtue of temperature difference. It is energy in transition process involving no heat exchange is known as adiabatic process. The adiabatic process is not equal to isothermal process. Adiabatic no heat transfer, but in isothermal energy contents and temperature of the system can be changed with the help of work. The energy transfer in form of heat by three ways, that is conduction, convection, radiation. Generally, the heat or the energy is transferred from high temperature to low temperature region, but the medium is different. If the medium is solid, that is known as the conduction. If the medium is fluid, that is known as the convection. If the medium is no medium, that is electromagnetic wave, that is known as the radiation. So what is the energy transfer? Associated with a force acting through a distance denoted by the symbol joule, denoted by joule or kilojoule. Then path function and point function. Magnitude depends on the path followed during the process as well as the end states. Point function magnitude depends on state only and not on how the system approaches the state. These are the important concepts of the thermodynamics. Thank you to listen here. Thank you very much.